In this video, we're gonna take trigonometric identities. To understand the difference between an identity and an equation, let's take this example. If x squared equals 25, so x equals plus or minus 5. So x equals 5 or x equals negative 5. This equality is true only if x is 5 or if x is negative 5. So this is an equation. An equation is an equality which is true for some real values of the variable, while an identity is an equality which is true for all real values of the variable. So the equation is true only for some values of the variable, while the identity is true for all real values of the variable. To understand this, let's take some examples. Cosine theta equals square root 3 over 2. This equality is true only if theta is 30 degree or if theta is 330 degree. Cosine 30 is square root 3 over 2 and cosine 330 is square root 3 over 2. So this equality is true only for some real values of the variable. So this is an equation. Example 2. Sine squared theta plus cosine squared theta equals 1. This equality is true for all real values of the variable, so this is an identity. Number 3, cotan theta equals negative 1 over square root 3. This equality is only true if theta is 120 degree and if theta is 300 degree. So cotan 100 is negative 1 over square root 3 and cotan 300 is negative 1 over square root 3. This is only true for some real values of the angle, so this is an equation. Sine pi minus theta equals sine theta. Pi is 180, so sine 180 minus an angle gives sine of the same angle. This is true for any value of the angle, so this is an identity. And in simple words, an identity is an equation which is always true. And a trigonometric identity is an equation which is always true and which involves trigonometric functions like sine, cosine, and tan, and the reciprocals. Let's start by the basic trigonometric identities. First, the identity of trigonometric functions and the reciprocals. The main trigonometric functions, sine, cosine, and tan, have reciprocals. The reciprocal of sine is cosec, the reciprocal of cosine is sec, and the reciprocal of tan is cotan. The reciprocal of a trigonometric function is the multiplicative inverse of the function. The reciprocal of cosine theta is sec theta, so cosine theta equals 1 over sec theta. The opposite is true, so sec theta equals 1 over cosine theta. Sine theta equals 1 over cosec theta, and cosec theta equals 1 over sine theta. Tan theta equals 1 over cotan theta, and cotan theta equals 1 over tan theta. Tan theta equals sine theta over cosine theta. Cotan theta equals the reciprocal or the multiplicative inverse of this. These are the ratio identities. The complementary angle identities. Complementary angles are angles where the sum is 90 degree, like 60 and 30, 20 and 70, 40 and 50, and so on. For any two complementary angles, for example, sine 60 equals cosine, the complementary of this angle, so equals cosine 30. Tan 20 equals cotan of the complementary of 20, which is 70, so tan 20 equals cotan 70. Sec 40 equals cosec of the complementary of 40 or equals cosec 50. If the function has a co, remove the co from the other side and the opposite is true. For cotan 70, remove the co to be tan of the complementary angle 20. So cotan 70 equals tan 20. And cosec 50, remove the co to be sec of the complementary angle to be sec 40. This is called the complementary angle identities. Sine of pi over 2 minus theta. Pi over 2 minus theta means 90 minus theta. So this equals cosine the complementary angle theta. Of course, pi over 2 minus theta and theta are two complementary angles. So sine pi over 2 or 90 minus theta equals, this doesn't have a co, so add co to be cosine the complementary angle theta. Also cosine of pi over 2 minus theta, This has a co, so remove the co to be sine of the complementary angle of this. So cosine of pi over 2 minus theta equals, remove the co to be sine theta, and so on. Tan pi over 2 minus theta, it doesn't have a co, so add co to be cotan the complementary angle theta. And also cotan pi over 2 minus theta, remove the co to be tan the complementary angle theta, and so on. Sec pi over 2 minus theta, add co to be cosec the complementary angle theta, and cosec pi over 2 minus theta, remove the co to be sec theta. Now the negative angle identities. Generally, the trigonometric function of a negative angle gives a negative value, but we have only one exception. For example, sine negative 30 equals negative sine 30. Tan negative 50 equals negative tan 50. Only the cosine of a negative angle gives a positive value. So cosine of negative 40 equals positive cosine 40. Generally, the sine and the tan of a negative angle and the reciprocals gives a negative value, but the cosine and its reciprocal give positive value. So sine negative theta equals negative sine theta. The cosec is the reciprocal. Cosec is the reciprocal of sine, so cosec of negative theta equals negative cosec theta. Also the tan and cotan of negative angles give negative values, so tan negative theta equals negative tan theta, and cotan negative theta equals negative cotan theta. Only the cosine and its reciprocal, the sec, of a negative angle give positive values. So cosine of negative theta gives positive cosine theta, and sec negative theta gives sec theta. Now the Pythagorean identity. Recall the unit circle. This is the circle centered at the origin and having a radius equal to 1 unit. This angle is theta, and this is a right triangle where the two sides of the right angle represent the x and the y coordinates of any point on the circle. The x coordinate of any point on the circle represents cosine theta, and the y coordinate of any point on the circle represent sine of this angle theta. And since this is a right triangle, so from Pythagorean theorem, x squared plus y squared equals 1. X squared plus y squared equals 1. Substitute cosine theta for x and sine theta for y in the Pythagorean theorem to get cosine squared theta plus sine squared theta equals 1. This is the main Pythagorean identity, and this is the most important one. Divide each term of this identity by cosine squared theta. Cosine squared theta over cosine squared theta is 1, plus sine squared theta over cosine squared theta is tan squared theta. This equals 1 over cosine squared theta, which is sec squared theta. This is the second Pythagorean identity, or 1 plus tan squared theta equals sec squared theta. By dividing each term of the main Pythagorean identity by sine squared theta, we get cosine squared theta over sine squared theta gives cotan squared theta. Sine squared theta over sine squared theta gives 1. This equals 1 over sine squared theta, which is cosec squared theta. These are the main three trigonometric identities. Each identity can be written in 3 different forms. Sine squared theta plus cosine squared theta equals 1. We can move the cosine squared theta to the other side with negative sign to separate sine squared theta in one side. Sine squared theta equals 1 minus cosine squared theta. Or we can move the sine squared theta to the other side with negative sign. So cosine squared theta equals 1 minus sine squared theta. Similarly, for the second identity, where 1 plus tan squared theta equals sec squared theta, we can move the tan squared to the other side with negative signs. So sec squared theta minus tan squared theta equals 1. We can move the 1 to the other side with negative sign. So tan squared theta equals sec squared theta minus 1. Cotan squared theta plus 1 equals cosec squared theta. We can either move the cotan squared to the other side, or we can move the 1 to the other side. Move the 1 to the other side with negative sign. So cotan squared theta equals cosec squared theta minus 1. And finally, move the cosine square to the other hand side, so cosec square theta minus cotangent square theta equals 1. Actually, we don't need to memorize all of these rules. It's very enough to remember the main Pythagorean identity and to derive the other ones by dividing by cosine square to derive the second identity, then divide by sine square to get the third identity, then move any term to the other side to get other forms of the main identities. Just put the trigonometric identities in front of your eyes while solving. This will help you to easily memorize the rules.